Temperature compensation devices and very stable power supplies help ensure tight frequency specifications within the automatic fine-tuning system. This concludes review number 4. Now stop the video and complete section D in your student workbook. In this portion of the video, we will examine TV remote control, beginning with the transmitting devices. There are two basic methods of transmitting control information from the remote control device to the TV. These are sound and light. The sound method works on the same principle as a tuning fork. Inside the remote control device are 3 aluminum rods. Each rod controls a particular remote control function within the television set. Notice that each aluminum rod is a different length. When any one of the rods is struck, its length will determine its natural rate of vibration or its resonant sound frequency. The resonant sound frequency of this form of remote control will range from 19 kHz to 45 kHz, which places this acoustic transmitter in the ultrasonic frequency range above human hearing. The control unit works by the user depressing one of the function buttons, which creates tension on the spring. When the button comes to the end of its travel, the spring will be released and recoil, allowing a small hammer to strike the end of the aluminum rod. The aluminum rod thus generates a specific ultrasonic frequency, which the television receiver recognizes as a function signal. After a predetermined time has passed since the function button came to the end of its travel, a silencer is sometimes used in the remote control device to end the vibrational ringing of the aluminum rod. Although acoustic remote control devices, such as this simple mechanical method, are outdated by today's newer electronic technology, they still have one advantage over modern remote control units. No batteries are required. The next logical step in acoustic remote control devices takes an electronic approach. Here you see the circuitry for an electronic acoustical remote control device. This circuit configuration makes up a Hartley oscillator, which can operate at the exact ultrasonic frequencies used by the mechanical remote. The advantage of this electronic remote control is that more direct functions are provided to the consumer than with the mechanical remote. When a function button is depressed, which in this case is actually 2 normally open ganged switches, additional capacitance is placed across the secondary tank circuit of this oscillator by the first half of the ganged switch assembly. This additional capacitance will place the oscillator at a predetermined ultrasonic frequency. The trimmer capacitors in each section provide the service technician a means to readjust the remote control device if any frequency would change. The second half of the switch assembly is used as an on-off switch, which only provides power to the oscillator when a function button is depressed. This arrangement conserves battery power and requires no thought on the operator's behalf to turn the remote on and off just before and after depressing a function button. The output of this oscillator is delivered to a special capacitive speaker which has an ultrasonic frequency range. Such a speaker is also known as a transducer. The newer TV remote controls are more compact and use light-emitting diodes which emit invisible infrared light. Infrared light, also abbreviated IR, is just below the frequency range of human vision. An infrared or IR TV remote control will contain very few electronic components. In fact, most of the circuitry used in a modern infrared remote control is built into a single integrated circuit. Each remote control chip has a keypad decoder section, an oscillator or clock stage, a memory